Hello and welcome. I'm here to do kind of a little tutorial on these restriction enzyme mapping questions, set number 1, so that you can try some on your own. So what we've got going on here is it's talking about mapping a plasmid called PGen 311, and it's got a total base pair length of 20 kilobases, so that's 20,000 bases long. So we know the size of it, and we know it's circular DNA because it's telling us it's a plasmid. And so what we're looking at is using this map as a guide to figure out the restriction fragment lengths associated with cutting this plasmid with 2 different restriction enzymes. Restriction enzyme 1 is EcoR1 that only cuts once, and then BAMH1 cuts 3 times. So this is what we're looking at, is actually called a double digest. I'll write that over here. So anytime you have, multiple restriction enzymes, double, my goodness. So it's a double digest, and we're looking at PGen. Sometimes, or most of the time, you can put the name of the plasmid in the middle, and then you want to remind yourself how many kilobase pairs big it is. So obviously if we add up these numbers, the 6, the 2, the 8, and the 4, we're going to equal to 20. But what it's asking us below are the lengths for the single digest of if we just cut it with EcoR1, so we kind of have to not worry about the BAMH1 for that, or if we cut it only with BAMH1 and kind of forget about EcoR1. So there's a bit of playing around here that we can do to figure it out. So most of these problems behave kind of like a puzzle. So that's another tip, is to kind of think about them in that way. I'm going to make this a little smaller here. Oh, it won't let me. Alrighty. So I'm going to circle first the enzyme that cuts more. So start with the RE, or restriction enzyme, that makes more cuts. So for the BAMH1, it makes 3 different cuts. We can see that it has a 2 kilobase pair, a 6 kilobase pair, but then we have this EcoR1. I'm just going to pretend like EcoR1 hasn't cut anything, and I'm going to add the 8 and the 4 together. So if I just look at the enzyme that cuts more times, which is BAMH1, I'm going to put 2, 6, and 12 for the single digest of BAMH1. However, if we look at where the Eco is cutting, EcoR1, I'll circle in red, it makes just 1 cut. So it's going to have 20, because it's just going to make 1 cut at 1 restriction site and have what was once a circular plasmid DNA. If it were just to have that 1 cut, it's just going to be linear. So when I digest with both of them, I'll put that in a different color, I'm going to get the 2 fragment, the 6, and then the 12 is actually getting cut, as it shows on this map, into 8 and then a 4. All right, so you can put them in order of length, that's fine too, but this is fine as well. So this would be an example of like the easiest type of problem you're going to get with plasmid mapping. They actually get a little more complex because instead of just having the map already made for you, like in sample problem number 1, you'll be looking mainly at gel electrophoresis banding patterns and making a circular plasmid map from there. So I would like to do the second problem with you as well. Oops, sorry about that. So it's not letting me get any zoomed in less. So for this, we're talking about trying to reconstruct a map for plasmid PUC23, so that's the name of it. And we're going to use the same enzymes in this, but a different plasmid, so different DNA. So we're going to use EcoR1 and BAMH1 to cut it. And because it has cut the plasmid DNA, it's going to produce these banding patterns in the gel electrophoresis. So this is a double digest again. It's going to show you the digest of what we get when we just do EcoR1, when we do BAMH1, and then both of them that are combined. So here's what we get out of here. We get 1 20 kilobase pair segment. I'm going to do that one in green. Maybe I'll keep it red like we did Eco R1 on the last one. Sorry about that, pen wasn't working. All right, and then we're going to look at then the BAM H1. Has 3 patterns. Then when we do them together, we see something different. So here's the dual digest, double digest. And see how thick this one is? When you get a thicker band, that's usually meaning that you have at least 2 fragments. So that means we have 2 fragments that are probably 3 kilobase pairs long when we finally get this map done. So I'm going to use my rule again of starting with which one of these has the most number of cuts, and that's BAM H1. So it's going to cut this plasmid 3 different times. And we know that it equals 20, so it kind of helps to see that, okay, 11, 6, and 3 are made. So what I'm going to do is I'm going to scroll down a little bit, trying still to keep my bands above visible. And I'm going to do a little bit of my map here. Let's just start with black. So I'm going to actually name it. It's the Puck 23, and it's 20 kilobase pairs big. Promise you will get a different amount of base pairs as far as that. I know it was the same as the last one. But what I like to do is just start one of my cuts of the BAM H1. I'm going to put BH1 right at the top. So if we think of this as a clock, we're going to put it right at the top of the clock. And then I'm going to kind of divvy this circle out in how much would be about half. So I'm not going to make a cut, but I'm going to erase this in a second. But that little tick mark on the bottom is about 10 kilobase pairs. I'm going to go ahead and remove it so that I can show that my BAM H1 probably going to cut maybe about there to get this whole fragment is going to be 11. I'm also going to erase that so it doesn't distract us. But then we also know that we had a 6 and a 3. So if that whole bigger chunk is 11, 6 and 3 is 9, right? To make this total of 20, I'm going to divvy this out, and I'm going to say, okay, the BAM H1 has to cut over here too, because this segment is going to be 3, this segment is 6, and then that whole big segment is 11. So being that I got 2 in look at my double digest now in green, I have to account for the double digest on the map. So I know somewhere in here the Eco R1 should cut, but I don't quite know where yet. But I can get the answer by looking at the gel. So I know that I have a 6, so I'm going to leave the 6 where I had it from just looking at BAM H1. I had an 8. I have an 8. So there's going to be a fragment of 8 in here somewhere, but I also have 2 3s. I've only accounted for one of the 3s right here. So I need another 3. So that's where I'm going to do first. I'm going to put in a 3, and I'm going to put it in. I'm not going to mess with the 6 and the 3 chunk. I'm going to mess with the 11. Because as you can see, there is no line up here on the gel for the dual digest at 11. So I'm going to split up my big segment that I said was 11, and I'm going to split it up into 8 and 3. So this section is going to be the 3. So there's where my second 3 comes in, and then this one's going to be whatever's left over at 8, and I'm going to label this cut as Eco R1. So now I have all the bands, 4 bands, even though there's only 3 on my gel. The 3 kilobase band is larger, so I have 2 of those. 1 6 and 1 8. If I add 8 plus 3 plus 3 plus 6, it should equal 20 kilobases. So that's how you would construct a map for a plasmid with restriction enzyme digests based on a gel. So go ahead and skip page 4 of this document if you're doing it digitally. I left it out of the paper copy, and so you're going to go on and try number 3, 5, and 6. I will scroll to number 6 because I think it's confusing the way I have it set out. For this one, I just want to give you some like lay of the land. These are the wells, are right here. And then that means the DNA is running this way. So this side is positive and this side is negative. So it's kind of like flipped on its side comparatively to some of the other gels that we've been looking at. So these little gray or black lines are the bands. Now, if they're big, like this one is really, really chunky, that might be meaning that there's probably 2 bands for this Eco R1 at the 5 base pair mark. So see if you can decipher these. We'll go through them all again, make lots of revisions. Just give it your best